Okay, so Universal Rotary, why did we get into that? Well, it originally started as a way to program universal or rotary features universally, meaning I can take that program from any machine Hurco makes with a rotary axis, whether it's an A axis, an AC, BC, or whatever. As a rotary axis, this program will work. So we're able to universally stretch that across our entire product line. Well, that morphed into being the program type that all of the new features, things like being able to use work offsets, G54 through 59, or any of the auxiliary work offsets in a conversational program, tool change optimization, things like that have all been put into Universal Rotary and is really the direction that the company is heading. That's going to be kind of the norm even for 3-axis programs. One of the first things that comes up if you start a new machine today, you're going to find that the Universal Rotary is the default type, and your program or your part setup screen will look something like this. Even on a 3-axis machine, you'll have X, Y, and Z, and then an A or a 4th and a 5th axis place to put values in there, even though you won't have a rotary on your machine. Let me show this first. If I go to this particular program I have open, you'll see that it's a universal program type. And you'll also notice that I can't select it and I can't change it. The only options that I have over here on my particular version of software is if this was not a universal, is to convert it to universal. So I'm running 10.02 software, which is pretty new, but it is shipping on some machines. So you'll see that we're definitely going down the road of making universal V-type programming. So with that being said, again, on a 3-axis machine, the part setup screen shows 4th and 5th are being used. If you're on a 5-axis machine, it'll say 4th and 5th. So Jason touched on this a little bit in one of his previous webinars, but I thought it was worth mentioning again here. If we go to our conversational settings under Utility, User Preference, and Conversational Settings, the fourth question down here says you want to display the machine axis for universal type. If you select yes to that, and then you go back to your part setup screen, it will show you by letter what axes you have on that machine. If it's only a VN10 3-axis, then you will only see X, Y, and Z. There will not be a 4th or 5th. If you were to plug in an A-axis, it would then show up. So a little bit of confusion comes in when we use the term Universal Rotary. People think it's only for rotary programming, and it's really not. It's just the type of programming we're going to use going forward. So let's go ahead and start into a little program here. What I've created is a very simple part, but it covers most of the things that people have issues or questions with when it comes to programming in Universal Rotary. I've got 2 features here, rotary slot and a rotary text. And then I've patterned those around the cylinder. That's the first thing that people have issues with, is getting those rotary loops or rotary patterns that they're used to work. I've got some simple holes drilled here at every 90 degrees, and I've milled a flat on the end of the part and then was able to pattern that. So that's kind of what I want to cover. At the end of this, I don't have anyone moderating with me today, but I will check the chat section for questions, and we'll see what questions come up there. And you'll also be able to unmute yourself and ask me questions at the end as well, and I'll try to do my best to answer those. But the first thing I want to do is we want to cover what the different fields are in the rotary programming, and then what they mean, and then we'll go into some of the rules and so forth. So I'm going to start a new program here, a new conversational program. And I'm going to start off with a Rotary Parameters block. So in my programming menu here, under Rotary and Transform Planes, I have Rotary Parameters. Now, we talked about this being a universal type program that I can run on any machine with a rotary axis. Well, I have to be able to somehow determine for the machine to know, or the control to know, what machine configuration I have. And we do that with this first pull-down menu called Rotary Orientation. So I can do a user-defined, which means I have to go in and fill out this information on my own, tell it by putting a 1 or a 0. 1 is on, 0 is off, what axis I rotate around, and where I want my 0 angle to be. Well, there are very, very specific reasons why I would do that, and almost never do we have to. Usually all we have to do is pull down and find the type of program or type of machine that you're running. I happen to be using today, my machine is set up as an SW, a 5-axis machine SW, which is an AB or a Rotary A. I selected that because Rotary A is probably the most common thing that people are using for the Rotary programming. But regardless of what style machine you have, select it there, and you'll see that it filled in these fields for me. They're grayed out, I can't change them, but they are there. I'm going to come back to this origin point here in a minute, but we'll continue down. So radius start, in the program, I'm going to be able to do a radius start, which is very much like your Z start in any other 3-axis programming, or I can put in a global value that the program will use for radial start. I have never found a need where radius start didn't work. It gives me the ability to use multiple radius starts in any block for whatever reason I may need to. So I usually leave that alone. But if you can find a reason or a need, then if you change that, then this radius field will open up and you can put a value there. One of the next things that we get people to talk about is they want to know how can I run my rotary with my tool off center, meaning off center of the y-axis. They want to step forward or backwards, either plus or minus away from the center of that cylinder by the radius of the tool, for example. This is where we do that. We put a positive or a negative value in here of whatever distance we want to step off of it. And then when I go to run this, I won't position directly on the center in Y. It will be off by whatever this value is. So that's an important field. And we'll talk about that a little bit later when I do an example at the very end. The next two are very, very special cases and are really only going to be able to be used on a 5-axis machine, and more specifically one with a tilting head. But whenever we call a rotary milling block in the program on a 4-axis machine, we have no option but to be 90 degrees or perpendicular to the cylinder. When we are on a 5-axis machine and we call a rotary milling block, the tool or the axis will automatically position whatever 90 degrees to that cylinder is. So I won't have to use any rotary position blocks or anything to make this work. If I wanted to, I could put a value in here, and it would then, on a 5-axis machine again only, it would only tilt that tool 45 degrees from the cylinder instead of 90. Maybe I wanted to use the side of an end mill to machine a chamfer around the top of a round part, spinning the C-axis, for example. We could do that, and this is where we'd set it. I do caution you to play around a lot in the graphics if you're going to do this, because some of the numbers will be numbers you have to play with to get it done because it wasn't intended to be done this way. So we'll leave that at 0 or at 90, and then along with that, if we wanted, then you could have the tool retract on whatever that angle is. So 99 times out of 100, if I just set this rotary parameters block and pull down whatever my machine configuration is, that's all I need to do, and it handles everything for the rest of the program. Just wanted to cover a little bit of that. The origin point over here is also really only useful on a 5-axis, but let's say we had an SRT machine, one with a swivel head, and I had a 10-inch square part that had some 3-axis work on it, and then up in the upper left corner, I had a little cylinder that was kind of sitting like a can of pop on there, and I wanted to engrave around the outside of that cylinder. Well, this is telling the control where the center of that cylinder I want to rotate around is in reference to part 0. So that does not have to be on the very center of the rotating axis. That's what origin point is for. So let's get into doing some programs. I'm going to insert a block here, and under Rotary and Rotary Transform Plane, we have a bunch of options that are only specific to Rotary. we have the rotary milling, which gives us a lot of the same features and things as we have in regular milling. We can do rotary lines and arcs. We can do a rotary circles, frames. And what these do is they basically are going to take this feature and wrap it around the cylinder that we determine. If I were to start out with, let's say, do a rotary slot, the block looks very much like it does in 3-axis, with the exception of the designation of axis start and angle start. Anytime we see the word axis, we can know that that is along the cylinder length. For example, if I've got an A-axis and the far left side of that A-axis, or the face of that, the face of that is my 0, then the axis would be along X and it would be along that cylinder somewhere. Then we have angle. That's obviously replacing what would be the Y-axis, and that's wrapping that around the cylinder. I'm going to go in here real quick and set up some stock geometry. I'm going to say that we're going to use a cylinder. Answer the right question here. It's going to be on an A-axis, so the cylinder faces to the left, the body runs off to the right. It's going to be 6 inches long, a radius of 2 inches. So that's what my stock's going to look like. Let's go back here to our block. And I'm going to do a rotary slot. I want to do a line. Let's make that 1 inch wide. Now the axis start. If the face of that is 0, I want to start in 1 inch from the end. And we're going to make the angle start. I want to put this at 45 degrees. So it won't be right on the A0, it'll be at A45 degrees. And the other important thing to note is whenever I'm programming in Universal Rotary, everything comes from the center of the cylinder. So here it's not giving me a Z start and Z bottom, it wants to know radius start and radius bottom. Well, my radius is 2 inches, so I'm going to wrap it to 2.1. And I'm going to go a ½ inch deep, so my final will be 1.5. Use tool 1. Let's make that a pocket. Now geometry. Let's go along the cylinder. We started at 2 inch or 1 inch. Let's go to 4 inches. And let's keep that at 45 degrees. And I will just append, actually we'll include arc on the end of that. Okay, so now if I were to draw that, we have one slot at the 45 degree angle. You'll notice that the Z up is here, so we're off 45 degrees. I'm going to make one change because of something else I'm going to do to it here in a minute. I'm going to start this at 2 inches. Okay, so now let's say that we want to take this feature and we want to wrap it around the outside of the cylinder. We want to do 4 of these equally spaced around the outside. So what we'll do is we'll just use a rotary pattern. Now, one of the things that people have had issues with in the past is they're used to the old rotary style and they were able to pretty much do a rotary loop on anything. If we do a rotary patterns and a rotary loop, that will work now on anything that is a rotary block. So anytime we're using rotary milling or rotary holes, things like that, we're able to pattern those using a rotary loop. If it's something like a 3-axis frame, which we'll do here in a little bit, that is when we're going to have to do something different. So here I want to do every 90 degrees, 4 times every 90 degrees. And then we're going to do a pattern end, rotary pattern end, at the end of that. Now when I draw that, I should have 4 of those going around the cylinder, like that. So let's do a rotary text the same way. So I'm going to insert a block. I'm going to go to Rotary, Rotary Milling, and I'll just do stick lettering. I'm going to position it by the center of the little box. Now axis, along the cylinder, along the length, I'm going to put it right in the center. That's 6 inches long, so I'm going to put it at 3. And the angle reference, I'm going to put at 0 degrees. We'll make the text 3 inches long and ½ inch tall. And I'll write the word Hurco. Radius start, 2.1. Let's go 1 inch 990, so 10 thousandths deep. I'm going to turn it so it's along the length of the cylinder and not around the circumference. And I'll use, I've got a small tool in here somewhere we can pick. All right, so now we should have the word Hurco engraved there at the 0 degrees. And now I want to take that and I want to rotate it around. Again, it's a rotary block, rotary stick lettering, so I can use my rotary patterns. Insert, rotary patterns, loop rotate. Again, 4 times, every 90 degrees, and then I'll have to go put that end in there. So once again, we're able to take a rotary block and pattern that to get the results that we want. So let's drill some holes around the outside of this circumference. We don't really have to go into anything rotary to do that. From holes, I'm just going to do an insert a regular 3-axis holes block. I'm just going to do a drilling operation. I'm going to start at 0.1 and minus 1 inch. So 1 inch deep hole, starting 100 thousandths above, using a drill. Now when I go to my next hole operation, now I have one for rotary locations. If I'm on a rotary machine, this should be available to me. I can select it, and there's a few things here that I can fill out. Number one is the axis. Where am I going to put this along the axis of the part? I'm going to go 5.5, ½ inch from the end. I'll do one at 0 degrees, and now it's asking me for the radius. If I put in the radius of my part, it will take that 0.1 and minus 1 inch and convert that to rotary. Let's do one at 90 degrees, 180. And 270. So here I can put the locations of the things that the holes that I want, and it will automatically, using that radius that I inserted in there, drill the holes where I want them. So they started at 100 thousandths above, and it went 1 inch deep. So it took care of that for me. That was one of the things that people had trouble with, so I wanted to cover that a little bit. Now the next thing is I'm going to mill a flat here at 0 degrees in 3 axis on the part. So I'm going to insert a rotary position block. And the reason I'm doing that is because the very next block is a 3-axis block, and there's nowhere in that block to put a rotary position or a rotary move. In all the other blocks previously to this, it was a rotary block, so there had an angle start and angle end and things like that. So now if I want this on a specific location on the part, I'm going to have to put in a rotary position block. Really the only thing I care about is that my A is going to 0, but we do have a few other things here that we could set. Reset rotary encoders, we're going to talk about that later when we try to mill like a thread on the outside of a part. Do I want this block to be a stop block, yes or no? If I had to flip the part, for example, something like that. There's some other things that we can put in here. But basically, all I'm really looking for is to make sure that I send this A-axis to the location that I want. Next, I'm just going to do a mill frame. And I'm going to start 1 inch in, 2 inches up. So if all my numbers were there correct, I should have a flat that gets milled on this part. Oh. What did that tell me? We just ran that. Gotta love it when it does this to you when you're doing something. All right, not sure what's going on here, guys. Oh, yes, I do. No, I don't. Yeah, it was operator error, as it usually is. Okay, so now we're going to have a flat milled at 0 degrees on the part. I was trying to start at 0.1 and go up to 1.1.5. So the way that I want to pattern that is, since I can't use rotary loop, if I use a rotary loop, the machine will work. It just will cut that flat 4 times in the exact location. It won't rotate. So I have to use something else. So if we look at rotary and transform planes, we have something here called transform plane groups. Most people associate these with 5-axis, but we can also use transform plane groups for things like rotating around the Z on a 3-axis part. If you want to just rotate the thing 45 degrees, or you want to do a pattern around Z, it's another way to do patterns. In this case, we're going to do a transform plane group rotate. We're going to rotate it 4 times, and we're going to rotate around the A axis, around X. I'm going to go every 90 degrees, and I'm not going to move anything. I could step this over a specific amount every time if I wanted to for each individual one. Then I'm going to go to rotary transform plane groups, and do a transform plane group end. Now it's one. It works the same way as patterns, it's just called something different. So now if I go to draw this, I'm able to take a non-rotary feature and pattern it around the cylinder using the rotary. So transform plane groups is how I would do that. So now let's, I'm going to start a new block, and we'll talk about doing rotary lines and arcs. I'll set up something the same size here. So let's say we had this cylinder, and we wanted to simulate running a thread with a ball nose end mill around the outside, or along the length of the cylinder. And I want to stop about 2 inches from the end and then mill a straight notch off the end of the part. The very first thing I need to do is I want to start out with a rotary patterns. I'm sorry, a rotary parameters. Tell it that it is a rotary A that I'm using. I'm done. That's all I need to do there. In the next block, we will insert a rotary milling lines and arcs. And just like in milling lines and arcs, this is going to have, starting with segment 0, and have as many segments as it needs to create this. And they're going to be lines and arcs, everything we're used to. It's just that the Y will now be wrapped around the cylinder in an angle. So I'm going to start a 1/2 inch off of the part to the left side of the part. I'm going to start at an angle of 0. I'll do 2.1, and let's go down to 1.8. I use a ball nose end mill. Let's find one in my list here. And we're going to keep it on the center of the tool. And when I go to next segment, we have line and arc that are available. I'm going to select a line. Now what I want to do is I want to travel from -1/2 inch, So off the part to the left, all the way to 4 inches into the part along the axis. So I'm going to put 4 inches. Now, what is the angle end? Well, that depends on what I'm doing. In this case, I want to wrap a line all the way around the part, stopping at 4 inches. Let's say that we had a 1/2 inch pitch. So every time it made a revolution, I wanted to travel 0.5 inches along the cylinder. Well, I could take 4 divided by 0.5, oops. That's going to give me 8 times, and then I could take 8 times 360. Keyboard here, where's my there? And that gives me 2,880 degrees. So that tells the rotary axis how many times to turn while I'm traveling that 4 inch distance. When I get there, I want to take a line off the end of the part. So in essence, I can keep going. Once I have created this little spiral, when it stops at 2,880 degrees, then it's just going to machine off the end of the part. So depending on what my needs are, I could add to that, or maybe go back the other way now and finish threading off the part, whatever you need to do. But that's how lines and arcs works. If I wanted to or needed to, one of the questions that we get again is, well, I want to run that off of the center line of the spindle. So let's say we take it 250 thousandths positive in the Y. So now if I were to look at that at XY, if I can stop it in time. No, I can't stop it. But anyway, it's staying. We ought to see it when we do the little line at the end here. We're staying off of the center of the part by that half or that 1/4 of an inch. Thereby we're cutting on the radius of that ball nose rather than the center. That's some questions that we get a lot. One more thing here. I'm going to insert another rotary position. So at the end of something like that, we would probably want to send the rotary position or the rotary axis back to 0. Well, we've just wound it up 2,880 degrees. So if I simply put a rotary position and I go to A of 0, then I'm going to get an unwind. It's going to have to unwind that 2,880 degrees. If I answer this first reset rotary encoders question to yes, in essence, that's putting in, like putting an M31 in our NC programs, but it's going to reset the encoder to wherever it is between 0 and 360. So when I tell it to go to A of 0, it only rotates a number of degrees, a few degrees, rather than 2,880 and have to unwind that. So at this time, that kind of covers everything I wanted to just show you. I'm going to open up, I'm going to stop our recording here.